the ones that we had trouble on and emphasize on how.
All right.
You had trouble on all of them.
Not
No,
all.
not 1,
Just
3.
three.
1, 2, and 5 are
Just
fine.
3, half of 4, half of 5, 7, and 8.
And 6.
And what are the ones that we need to do
Six
all of
wasn't
it? So
that
that's
bad.
3.
3.
3, 4, 5, 6, and 7, and 8.
Okay, I got 6 and half of 4 and 5.
Well, that doesn't. Well, you didn't get the other half, so therefore.
3. Show. Oh, that's question exercise. 3. The diagonals of a rhombus are perpendicular. I got to prove that statement. The diagonals of a rhombus are perpendicular. The diagonals of a rhombus. So even before I draw it, how are you going to show the perpendicular?
Well, first you got
Big idea. How are you going to show the perpendicular?
you negative slope.
Opposite
slopes.
reciprocals.
Slopes.
Opposite slopes. Yeah, big picture. Let's just calculate the slopes. Slope formula, so we need the 2 points. So coordinate plane.
It tells you what to make the
Oh, does it?
vertices of them too.
It's nice.
Let the vertices be 0, 0. Okay, I think we drew this one on it. So rhombus. Is this how they drew it?
No.
No? Did they drew it
We drew it like we did in class.
like this?
Yeah.
All right, that's probably more parallel than a rhombus, but all right, so we got 0, 0. Then what?
We have the B.
A, comma 0.
A, comma 0 for the bottom.
Okay, so that
right
would be
one.
this one. So that would be A, comma 0.
Top right
Across
is
from
A plus B, comma C, and then BC.
And then BC. Okay, and that's how we did in class, right? So we said from here to here is B. So then to there would be B plus A. Why? Because it's proportional.
Okay.
Okay.
Plus A, yeah.
Okay, or congruent, I should say. And we need to prove that the diagonals are opposite reciprocals. So well, there's nothing really to do here other than do the slopes. Okay, so I'm going to do dark one first, right here. So y2 minus y1, so that would be c minus 0 over a plus b minus 0, which just leaves us with c over a plus b. So what's the opposite reciprocal?
Opposite reciprocal would have to be negative A plus B over
C.
C.
All right. So we are looking for an answer of a plus b over c and with a negative attached to any one of these, right? All right. So that's probably where you guys got lost on the thing. So let's see. That would be 0 minus c. Well, there's my negative right there. And a minus b, well, that's not very nice because it doesn't look like we're going to, it's a little bit of a math trickery going to go on here. We're going to get negative. So the question is this equal to that? So I'm going to put that next to each other. Well, we can't put equal yet. So we got negative c over a minus b. Well, we can see that they're reciprocals of each other, right? Question is, are they opposites of each other? So I'm going to take this negative and write it as what? I'm going to write it as a negative 1. I'm going to put a negative 1 and okay, that would be a plus b over c. It still doesn't look right, or does it? If we factor out a negative 1 from the top, or if we multiply top and bottom by negative 1, let's multiply top and bottom by negative 1, because that's just 1 over 1, right? Well, that would give me what? A positive c over negative a plus b. Does that look like this now? It can if we distribute the negative to the, nope. Now it looks like negative a minus b over c. So this is just going to be a mess around with the negative symbol of how we do this. Okay. How are we going to do this? How are we going to do this? Let's see, did I do it right? I did it right. Okay, that's that thing, and that's this thing. C minus 0 over a plus b. So we would get c over a plus b. So I got to turn that into any one of these. This one, or this one, or this one? Well, I mean, the easiest way is just simply multiply this one times a negative. So I'm going to take the bottom and multiply it by -1. That'd be the easiest way. And then it turns into this one right here. Can you see that? So this one and that one are opposite reciprocals. So clearly they're opposite, or they're reciprocals of each other. So we multiply the bottom one times that. It's just a matter of just messing around with it. All right. So that was 3.
The
4.
4B.
We're gonna run out of time for the review, but we're gonna do 2 days of it. 4B
4B, yeah. 4A
I got
was,
A. But
A was easy. All you gotta do is bring the same stuff.
has length equal to the average of the base lengths. What does?
the median.
The median. Okay. And does it tell us how to set it up? It kind of sort of
It
does.
shows you.
Just
the
doesn't tell
picture.
us the median, right?
Yeah.
So
Well, we can figure
is it
out.
trapezoid or just trapezoid? Or is it isosceles or is it just trapezoid?
Just trapezoid.
Okay, so 0, 0. What do we got?
DC. DC
Ooh,
and A 0.
okay. So the first thing we need is the median. All right, so this one would be this plus this divided by 2. So that's B over 2. And this is C over 2. And this one is, however you want to write it, A plus D over 2.
And then just C over 2.
C over 2. Okay. And there's your median. And we need to show that, what do we want to call this? Do they give you letters or anything?
Yeah.
N, O, and
So
P.
you just do the distance formula for
Yeah.
The top, and then you add them together and divide by 2. You can
Yeah.
yeah.
And we got to show that it's half. Is that what we're trying to show, B?
Yeah.
Yeah, that the length is equal to the average. In other words, the 2 bases divided by 2. So it's just a matter of, it's not pretty. Distance formula. All right, we'll do the median first. All right. So that's the 2 x's added together. I'm just going to go ahead and do this really quickly. Like I can see like a common denominator. So that's going to be A plus B plus D over 2. Right? And I got to square that. Ugh.
So
A plus B plus D over 2, and that's squared. Oh, wait, we got to subtract. What am I doing?
A plus D minus.
Thank you. A plus
D,
D,
minus,
A plus
minus,
D
minus B.
minus B. There we go. A plus D minus B over 2. And to that, we are adding 0 squared, right? Because C over 2 minus C over 2. So it's just this. I'm going to choose not to even mess with that sucker. I'm just going to leave it like that. Maybe I'll have to later. I don't know. But the square root of that is just simply A plus D minus B over 2. Yeah? I took the square root of that right there. I'm not going to square it and then take the square root. Okay, so I got to show, I mean, you can already see the 2 here. So what I really need to show is that the 2 parallel sides are equal to A plus D minus B. And since that is divided by 2, then okay, let's see what we get. One piece at a time. Distance of this one. So the square root of the x's subtracted. So that's what? D minus B squared plus
Plus.
C was 0. All right. So this turns into D minus, you can kind of see what's happening here. So that just turned, this part right here, this is 0 squared because it would be C minus C. So it's just D minus B quantity squared, take the square root of that, and you get D minus B. To that, we're going to add this distance, which is, say, well, we're done. So there's the distance, and we just proved that this one was half of it.
Hey, is it, sir?
Yeah.
Is it okay? Because on that one, I didn't write out the full equation because I really didn't have enough room, so I just wrote.
Neither did I.
Yeah, all I did was I wrote. So once I figured all the things, I did the math. I said, oh, AD plus BC over 2.
I mean, I did the same thing. As soon as I realized it was, I stopped working.
Yeah.
All right, what else?
The
5.
Second question.
There's 2 questions on 5?
It asks you 2 things.
Prove that the
You
segment
can't
joining the
use-
midpoints
Let's do
of the
all.
diagonals of the trapezoid is parallel to the bases and equal to, well, it's literally what we just did. Prove that the,
Just do all of 5.
well, didn't we just do the second part? Prove that the segment joining the midpoints of the diagonals of the trapezoid is, we didn't show it was parallel, and that the length is equal to half the different, we just did that. Why are they having you do that a second time? We didn't do the parallel part, but we did the half. So we just got to do the parallel, okay?
Well, the parallel part we did on 4 too. It was 4A.
So we did, well, then why are they asking question 5? It's still the same trapezoid. Trapezoid didn't change. Yeah, I mean, the second part there is literally 4B. That's dumb. And then why is this got to be this got to be a different question. Prove that the segment joining the midpoints of the diagonals.
Yeah, the diagonals.
Oh, it isn't the same question. All right. Me that's dumb, not the book. All right. Diagonals. Prove that the segment joining the midpoints of the diagonals. So the diagonals would be from here. Oh, I'm running out of space here. So that would be one diagonal. Prove that the segment joining the midpoints, so that right there, is parallel to, is that what it says?
Yes.
Yeah. I got that.
And has a length equal to half of the difference of the length of the bases. So once again, we just got to show that it's equal to the thing that I just erased. What was it? A plus D minus A, B? What was it?
Yeah.
Minus B over 2. So if we show it's that, then we're good to go. All right, well, let's go.
First, we gotta prove it's parallel.
I thought you said you already did that.
That was easy, actually. I did that.
You did that in 4A?
No, you did it.
You did that for 4A and 5A, or there's no real A.
I never did it. I showed the median. I didn't show that the
Yeah.
segment joining the diagonals.
Yeah, but in 5 it asks you to prove that.
Agreed. So I'm saying I haven't proven this yet. I did prove that in 4A that the median is parallel, but not the segment joining the midpoints. Okay. Well, it's still, we just got to come up with the thing. So when we get these 2 answers, I'm gonna write them down here. Otherwise, it's gonna be hard to see. All right. So midpoint of this one right here would be B plus A over 2. There's your X, and the Y's would be C over 2. And that's this point right here. And then that point right there would be this one, and that would be what? That would be D over 2 and C over 2. Okay. All right. If we already determined that the slope was 0 for the bases, right? On 4A. Okay, so we just got to show that the slope here would be 0. Well, it's easy to see that you subtract the y's, you get 0, and since the x values are not the same, I don't know what we get on the bottom, doesn't matter. It's not 0, so boom, there's 4A or 5A. Now we got to show that this is equal to half. Is it really half the sum? This is amazing. I didn't realize this was true.
Half the difference.
Not half the sum, half the difference. Oh,
So
right.
Now this is why this one was definitely hard. So you had to.
But we got to subtract.
It was the same thing.
Erase too much.
It was the same thing. It just there was so much.
I erased too much. I don't even know what the difference is. So we would
A
have,
plus AD minus.
well, this is the sum.
BC over 2 equals EF.
This is the sum. Do you remember what the distance of the top was?
It was B minus D.
That was the B minus D,
Or no, it was D minus B.
D minus B.
Yeah, because it was A plus D minus
It
B, and
was.
the bottom was A.
And then the bottom one was A. So, well, obviously you can't do small minus big, so it's going to be A. Now be careful, it's going to be minus plus. Why am I doing that? Because you would be subtracting that to distributed on the inside, so it'd be both minuses. Okay, and if we can show that's over 2, then we're good. All right, there we go. It's going to be. All right, distance formula. Well, we can already see that once again, the y's, we're going to get a 0 squared. So we just need to do the x's. We don't even have to square it because we know the square root's going to go away. So all we have to really do is subtract the 2. All right, so if we do d minus b plus a over 2, well, there you go. And you're like, wait a minute, that's not the same. How we can do the trick with multiplying by negatives. So that would be, or we could do it the other way. If you don't want it, you can do b plus a minus d. And we're going to have to do, now we're still going to do the negative trick. So let me show you the negative trick. So we'll do it the other way. We'll do this minus that because that's the more natural way. So d minus b minus a divided by 2. We got to make it visibly look like this. So we're going to multiply top and bottom by -1 and then do something. So that's going to turn this negative, and that positive. That works. But we also got to multiply the bottom times a negative. We make a mistake somewhere? Because this should work. It should work. I mean, this gets the top to work, but we're left with a -2 on the bottom. We want a +2. Let me do the subtraction thing again. Maybe I made a mistake. So the top one would be d minus b, and the bottom one be minus a, because we'd be subtracting. So there's the, nope, it's a minus. That's what it turns into. Does that look like that? If we multiply, yeah, we're left with that negative. Left with that negative. Must be another trick somewhere. How do I turn that into that?
Would it be d minus b?
For which one?
Yeah, how do you get d plus b?
Because remember, that's the short segment. This is the long segment. So when it says the difference of the two segments, I can't do this segment minus this. I get a negative number. So it would have to be the long one minus the short one. The long one is a. The short one is correct, d minus b. So it would be a minus d minus b, which turns the d negative and the b positive when you distribute. This is a trick with a negative. I'm just not seeing it. As we multiply the top times a -1, we get exactly that right there. We get a negative d, a positive b, and a positive a. But I can't multiply just the top by -1. I got to multiply the bottom times a -1, which gives us a -2, and that's not what we want to get a +2. I don't know. I wanted to give that one some thought. That was 5, the second part of 5b. What was the other one?
7 and 8.
We're just gonna figure out what it was like.
Yeah, I couldn't understand what it was asking.
All right, I'll just show you the setup then. 7, prove that the figure formed by joining in order the midpoints of the sides of quadrilateral ROST, and they give you the picture, is a parallelogram. We've seen that, we actually did this, well, we've seen that it forms a parallelogram before. So you're given this quadrilateral ROST, and it looks like basically that. And ORTS. So ORTS. And you get coordinates, and it says, prove that the shape, I said shape instead of figure, they say figure, formed by joining in order the midpoints of the sides. So the midpoints of the sides are here, 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 here. ROST. So I'm going from here, oh, here, here. So that this right there is a parallelogram. That's what they're trying to prove. So how do you do that? Slope have to be the same. Slope have to be the same. And then once that's done, you're done. Now, there's alternate ways you can show that. Let's see, thinking back to chapter 3 or 4, we did parallelograms. If we show that two sides are both equal and parallel, so if you wanted to go the distance formula route rather than calculating the slopes, slopes are a little bit mathematically easier to do. Does that make sense? And then 8 is, somebody read 8.
Prove that the quadrilateral formed by joining in order the midpoints of the sides is an isosceles trapezoid, or of an isosceles trapezoid is a rhombus.
Okay, so an isosceles trapezoid, show that the midpoints is a rhombus?
Yeah.
It would be the same thing. So for a rhombus, though, the easiest way to do it is just show that these distances are all equal. And then you don't have to do anything with parallel. You could, ooh, that 5 is bothering me. And the answer in the book is no different than what we did.
Thanks, book.
They don't actually do the calculation. They just say, show that this is equal to 1/2 of the difference of the two. Well, that's what we just tried and we failed. All right. Practice test. Now, I have, when I make a test and I do it on the computer, I have a program for algebra and I got a program for geometry. And the program for geometry doesn't have midpoint and distance in it. So I have to go back to the algebra program to do that part of the test. So you're going to see a very weird test other than the fact that I also stapled in the wrong spot, or I should say the copy machine. I'm the one that pressed the button though. So the first part I actually got from the algebra program. So you're going to see 2 pages and answers to the first 2 pages. And then I started the geometry program and I did the last part, which is from the geometry book. So you're going to see a total of 4 pages. The first 2 pages have answers and the last 2 pages, and they're all labeled 1, 2, so forth and so on. Jack's not live, is he?
I don't
I
know.
don't think so. He's
Turn off
doing
the
something with
projector.
his dad, is what Mr. Fuller said.
All right, I will go over as much or as little as this as you want. We're all going to look over every question, and then if we want to go over it, we'll go over it. If we don't, we won't. All right, so the first 4 questions, I gave you more. I'm not going to ask you 4 of these on the test. I'll probably ask you 2, or maybe 1. I haven't made up my mind yet. It's either going to be 1 or 2. First 4 questions are using the distance formula. Let me share this with so they can finally see something other than the back of my chair. Okay, first 4 questions are distance formula. You guys want to see one or you got this?
Got this.
Ben says got this. Now be careful. I'll just say you can look at the answers. They are not asking you to pull out a calculator. They are leaving it in terms of a square root. We did a couple of these in my other geometry class, and you get the square root of, I don't know, 84. Well, you need to simplify the square root. So if you get square root of 84, then you got to simplify the square root. Well, yeah, and then the issue with the showing the steps is that if you don't, then you end up doing too much in your head, and then but I'm also not a big stickler for once you can see what it turns into. I mean, if it says the square root of I don't know, 16 plus 9, and you immediately put equals 5, I get that. I mean, I get the fact that you can add 9 and 16 and then take the square root of that answer. All right, McKinley, we good? 1 through 4. All right, how about number 5? You know what you would need to do there? What would you do? Because it says calculate the slope, yes? Where does it say that?
I don't know, maybe in the instructions.
Say again? Which coordinates? Perfect. Perfect. Segment. Yeah. Find where the segment ends. So -4, -2, and 2, 2 for number 5. And then just plug those. So it's just basically like the same question, except I gave you a picture instead of giving you the coordinates. All right. So that's the first 8 questions. I will not give you 8 questions on the test on that. Max would be 2 and 2. All right. 9 and 10 is just basically calculate the slope. You okay with that? Everybody knows slope formula: y2 minus y1 over x2 minus x1. Shame on you if you miss 11 or 12. Why am I saying that?
Someone's gonna miss it.
I sure hope not. But why am I saying shame on you for 11 and 12?
If you do, you're gonna be an idiot.
Because it's literally in the formula. I will give you slope intercept formula. Well, you just take the number attached to x, that's your slope. 13 through 16 are the ones that are just slightly tricky. You have to know what it means when 2 lines are parallel. If 2 lines are parallel, what can you say about their slopes? 13 and 14. They're parallel, they're the same, right? And if they're perpendicular, opposite reciprocals. 17, 18, 19, and 20 are your midpoint formulas, which we just did a whole bunch of those. And you guys were doing those in your head, so no big deal there. 19 and 20, I gave you a graph of that. So obviously, as McKinley said, you need to find the endpoints. And that's it for, it's all algebra in essence for this one, but that's it for that thing. Okay, so now the second confusing part, we start over again with question number 1, except it's really not question number 1. And it says sketch a graph of a line. Who remembers how to do on that the third page, question number 1? Let me pull this up for my share. What do you got, Ben? 13. Well, it's number 1, but
All you gotta do is you just find the slope. Same thing. So
no. It says
find the slope of a line parallel to each
nope,
line.
not that one.
Might say 13.
Because I made a mistake. Flip over to the next number 1. That's the one we're on.
That's the answer sheet.
Flip over to the next page.
All right. Find the slope of each line.
No.
Wrong page.
Sketch the graph of the line. Keep turning.
That's the answer.
Now keep going. Very next page.
Oh.
There we go.
Okay. Graph the slope. You just
What are you gonna do?
Y-intercept form and you're good.
Do what?
Y-intercept form.
You could, right? You could put it into y equals mx plus b, or an easier method would be, who remembers?
The y and the x.
So we better do this one.
The y where the y-intercept is and the x-intercept.
There you go.
That's what I was trying to say.
You remember how to do this? We let x equal 0 and we let y equal 0, and then we find out what values we get. And why does that make it easy? Because it's really easy. If you let x equal 0, 2 times 0 is 0, so it's just 5, y equals 10, which gives you 2. So when x is 0, we get a y value of 2. Well, there's 1 point, so 0, 2 right there. And then we let y be 0, so that goes away, and it says 2x equals 10. So now this is where you'll trip up. It wouldn't go 0, 5, it goes 5, 0. Because remember, on the second one, you let y be the value 0. If you're going to make a mistake, it's when you let y equal 0. Third mistake is when you graph this, you just really mess it up. Like you do it opposite. So there's your 2 points, play connect the dots, and you're done. I won't put 2 of those, but I'll put 1. McKinley, yes, no, maybe?
I got it.
Okay, cool. And remember, we always, if it's in standard form, if it's a linear equation in standard form, we always choose to graph the intercepts because it just makes it pretty easy. The only time it doesn't make it easy if the number, the C value is not divisible by the coefficients of X and Y. If that can't happen, you just get really ugly intercepts, but you can make an approximation of where it is. All right, I gave you a whole bunch of systems of equations, but I really just gave you all 4 flavors. The first flavor is you simply add. The second flavor is you subtract. The third flavor is you multiply one of the equations. And the fourth flavor is you got to multiply both equations. You want to do some of these? And say no. McKinley, you want to do some of these? No. Allie? You sure? You guys can do these all by yourself?
I'm already doing them.
All right, we better do number 4 because I don't believe you.
Wow, thanks. Thanks for.
All right, Ben, look at number 4.
All right, I'm looking at number 4.
Do we have to multiply or can we add or subtract?
Simply add.
No.
What do you mean, no? Yes, we can add.
Well, we can, but it's not going to get us to the answer.
Technically.
Why is adding not going to get us to the answer?
I see.
On number 3, if we add, guess what happens?
We'll get to the answer.
Because the x's would drop out. Why can't we add on number 4, McKinley?
So we're turning to negative.
Okay, so this is the one, number 4, where you want to subtract. But remember, how do we subtract?
By making everything the
Opposite. Right. And that's because subtraction is the same as adding, the opposite. So I guess technically I'm wrong by saying we don't add because eventually we do add. But after we decided we want to subtract the second equation from the first equation. So when you change all the signs and you add, let's see, the x's would go away and you would get with negative y is equal to positive 1. Is that right? Yeah. Therefore, y is equal to, no, negative 1. Then you take that value, throw it back into the either equation. Oh, that's a lot of negatives floating around. Doesn't matter which one you choose, including the one that you changed all the signs. Let's see what you get. And then lastly, the common mistake for a high school student is you do all that work. And since we solve for y first, when you get whatever x is, let's see, what is x?
X is 1.
Let's see, if I throw negative 1 into the top.
No, it's not, Anna, because you're getting them wrong. It's negative 3 plus 4 is 1. And we have negative 4 plus, negative 4y plus y.
Who's arguing what?
It's negative 1. Y is negative 1.
Yeah, we got that.
Yeah.
We're talking about x.
Then it's 1.
No, it's 7.
No, it's 1.
It's 7.
If y was negative 1, then that makes that 4. And because of that, it sees a negative 7.
Okay.
Just 7, actually.
Which is 7.
As I told you.
All right. Nice job. Both of you.
Thank you.
All right. Even though better job for Anna. Stuck to the guns.
No.
All right. Wrong book. I'm looking at the book. I'm like, that's not what we're doing. System of you sure you guys are good with multiplying both equations?
Yes.
All right. McKinley, look at number 6. Tell me there's not a right or wrong strategy. What's your strategy for number 6? We won't solve the whole thing, but what's your strategy for number 6?
Multiply the top one by 6 and the bottom one by 5.
I'll just give you, and that will work. I'll just give you one bit of advice. We love it when we add. We don't like it when we subtract, right? So you would prefer where you don't literally match the numbers. You have opposites, like a 4 and a negative 4, or a 10 and a negative 10. Yeah, I would make one of those. He's matching the x's, not the y's. That would be my choice as well too, because to match the y's, we got to get a 70. That's a pretty big number. So I'd match the x's, and I would multiply one by a positive and one by a negative, and yeah, we're gonna get to 30 and a negative 30. That's what I would do. Okay. And then we arrive, I think it's just one thing left. Oh no, some more things. All right, point slope formula. Make sure you can find this in your book of truth because we're gonna use this a lot. Point slope formula, y minus y1 is equal to m times x minus x1. All 4 of these are using point slope. What's the difference between 7, 8, and 9 and 10?
9 and 10 both have coordinates, while 7 and 8 have slopes.
So which one is easier, 7, 8, or 9 and 10?
7, 8.
You're just literally, there's no math involved. You're just plugging in numbers. Okay, there's a little bit of math when there's a negative involved because it's minus, so it turns to a plus. The work involved is 9 and 10, but what is the work? What do we need to find?
The slope.
We just need to find the slope. So for instance, on number 9, that would be what? 4 minus 5, so it'd be 4 plus 5 over 1 minus 2, which gives us 9 over -1, so we get -9. Did I do that right?
I think you need a -5.
No, because it would be 4 minus 5 and 1 minus 2, so -9. So we got a slope of -9. Which point do we pick? Does it matter?
No.
So you'll get 2 answers, I believe, because we did this in the other geometry class. I believe that they used that one right there in their calculation. But if you use I would have chosen the other one because it's got positive numbers, but you can choose either one. You're supposed to ask questions if you're tentative on that one. So that takes us through 10. These are good questions here. But if you're going to trip up, notice what the instructions say. Unlike the previous ones. Slope intercept form. So you're still going to use point slope form to start. Let's do one of these. You're going to still use point slope to start this, but you're going to wind up with slope intercept form. You just do the distributive property. Okay, which one do we want to do? 12. So it says point through 4, -2 that's perpendicular to that slope. So what's the slope of our line? 3/5. So I put a 3/5 for M. It goes to this point. The X value is 4. And the Y value is -2. So -2 is +2. So Y plus 2 is equal to 3/5 times the quantity X minus 4. Oh, we got to do some math. Ugh. Oh, this is painful.
Can we just leave it like that?
No, because it says,
It says
oh, it says point slope. Oh, I wanted to do Y intercept. Okay. So let's do 13. Yeah, you're right. This is the answer right there. All right, number 13. What's the slope? What is it?
1/5.
No,
Well, oh, which line?
of the one that we want.
Oh, -5.
-5 will be our slope. Let's hope the math works this time. So X plus 2, Y, because -2, so -2. And let's see, that would be Y minus 1. Oh, joy, look, no fractions. So we do the distributive property. So Y minus 1 is equal to 5X plus 10. Add 1 to both sides, so we get Y is equal to 5X, add 1, plus 11. Check, somebody?
That's
Answers?
correct.
Okay.
That makes sense. Yeah.
Cool. The ones that, not these right here, but the ones you might, are the point slope ones where they give you the 2 points, and you may choose the point that the one they don't, if you like, well, that's not what I got, just plug the other point in and see if you get what they get.
Actually, I think your book says you're wrong.
What does the book say?
Sorry, not the book, the back. It says number 13 equals Y equals -5X plus 3.
This is plus 3?
Yeah.
Well, where was our mistake?
No, we did everything right.
Well, let's see. Y minus Y1, that's Y plus 2. I think I flip-flopped the X's and Y's. That's what I did.
Yeah, that's what you did.
Is equal to what? It was -5. -5 times X minus 1. That's what I did. Flip-flop the X's and the Y's. So Y plus 2 is equal to -5X plus 5. So there's our 3. So Y is equal to -5X subtract 2 from both sides, plus 3. Okay, McKinley found the mistake. Plus 1 from McKinley.
And I still have that plus 1.
You
here.
said about, yes, that's exactly what was in the back. Those are literally your words.
No, I didn't say that. I said, yeah, that's the answer. I wasn't paying attention.
I know.
So why did you say that?
Because I thought that's what I got too.
We both screwed it up in the same exact way.
Why do you think? Because you did it. You did it better.
Because
This is why you check it, and then you become more aware of where your mistakes occur. Like, oh, last time I did this, I messed up on the X's and the Y's, and then you pay more attention the next time that you do one. And that's it. 14 is the only tricky one. Why is that tricky? It does, but why does that make it tricky?
X equals 0.
But what does that mean?
That's it's going to be a vertical line.
What is going to be a vertical line?
So, yeah.
You sure?
No.
So it says perpendicular to the line x equals 0. What's the line x equals 0? Think about it. What's the line x equals 0? Okay, this is, once again, this is your standard high school mistake is if you're going to make a mistake, it's going to be on horizontal vertical lines. You just got to be part of you, right? We have x equals k and we got y equals k. Which one is the horizontal? Which one's the vertical?
Y is horizontal.
Y is, you just said both.
Sorry,
Y
I
is
thought
horizontal.
horizontal.
Okay, so x equals 0 is what? A horizontal or vertical line. Okay, so it says perpendicular to a vertical line. I don't even really care where the vertical line is. It is the y-axis, by the way, x equals 0. So what is something that's perpendicular to that line?
Horizontal.
And what's the slope of a horizontal line?
Y.
0.
0. So we know that m is equal to 0. So that's what we're going to throw into point slope. Hey, we like that. Why?
Why?
Why? Because it's going to cause that entire one side to go away. We'll turn it into 0. So when we throw a y, let's see if I can do it right this time. Y minus 3, so y plus 3 is equal to 0 times x minus 4. But if I were thinking ahead, I wouldn't even need to write that because I know that 0 times that is 0. So we get y plus 3 equals 0. In other words, y is equal to, oh, I hope I got that one right. Somebody check me.
Yeah, you
Yep.
did that right.
Thank God.
Yep, you did that right. 100%.
Woo. Y equals to -3.
Finish this.
Field day tomorrow. You're going to forget half this stuff. We're going to come back Monday. We're going to do this again. And we're taking the test on Tuesday. And then Wednesday, Thursday, Friday, semester final review. And then I'll see you. What day is our final?
The second day?
I think
First
so,
or
yeah.
second class?
Second.
Okay. And I'll see you on Tuesday. And that's when your book is due.
Sir, I have a big question.
They are, but why do you want to hold on to your math book after you're done with the final? So bring your books to class. We'll turn them in and then we don't have to worry about it.
I
And
have a
I'm
question.
free.
Yeah.
So,
Homework.
Homework.
so you go to homework. Well, question.
I still owe you the answer to that one.
Which one?
The one that we couldn't
Oh,
figure
yeah.
out. Well, I mean, we figured it out. We just,
Oh,
the
yes.
one little tiny piece we got to fix.
I remember my question. So the chapter lessons 13.8 and 13.9. Those are gonna be on the test.
Were they on what was in front of your face?
No.
Okay. I don't give practice tests and say, "Hi, I didn't put it on the practice test, but you're responsible for everything.
Okay.
Joke's on you." No, I don't do that.
And if we want to, we could look at the thingy, the gingerbread TED Ed thing.
We've got 2 minutes.
I know.
What is it?
Ben does not like free time. This is what I've learned.
TED
He's
Ed
very angry at me.
gingerbread paradox.
Okay, e-learners, if you have any questions, make sure you send me a chat. That will do it for today.